So, hello everybody, my name is Gennaro, I'm from Strathclyde University in Glasgow, as you might have guessed. And yes, so my presentation will be about developing a new way of entering text in ASE application. We will see how that's done. I know what you think, that's a massive time, but it's just to get the idea of the techniques, the various techniques that I'm using in trying to improve the present ASE applications that we have. So, yes, spacebar's the way. Okay, so basically, I knew nothing about aphasia or the therapeutic approaches or what was out there. My interest only lied with accessibility, and I thought it was an interesting area to look at, how to help people with that who had a stroke and can no longer speak, and just to get an idea of what these people used at present, what was out there for them. So the best way I thought was to actually speak to a professional, which I did. I got in contact with a speech therapist in Glasgow who was very kind and let me interview her for 40 minutes. Yeah, could you believe that? And yeah, and so I asked a lot of questions, and basically the conversation went along, and I asked about what kind of technology people use and what kind of devices and stuff like that. So she said, well, there's no much use of this technology in hospitals because there's heavy protocols, there's no Wi-Fi access, and there's data security issues and stuff like that. But there's loads of use of this technology without patients. So she said, we have a lot of people, of outpatients that use these things, and the majority of them use iPads. So, and use apps like Therapy for the therapeutic side and the actual improvement of speech, and stuff like Grid Player because it's free for actually voice generation. But the issue that kept popping up was that they're tremendously slow, as you might know better than me because you've got more experience. And she was talking about horror stories of people taking 10 minutes to form a sentence. Now, bear with me if you know what, because I don't know if you know these apps or if you've ever used them. But it's basically you start off with categories with topics, and then once you select a topic, you've got a range of words that you want to select, and you just press, and then you add a stop word, and you press again. You go back, and you see by the time you finish with it, 5, 6, 7 minutes have passed. The other person is getting bored, interrupting you, get on with that, stuff like that. I have things to do, and stuff like that. So I thought, that's not very accessible, is it? So I said, okay. So I left the speech therapist about nearly a year ago, saying, I'll try to make this better. And the practical part of this has only started about a month ago because I had to get a feeling for the field and for the actual techniques that were out there to develop my idea. And my idea was to use text entry techniques. So to use text entry techniques to actually improve these apps. To use natural language processing. What do I mean by that? Well, I thought if the interface could dynamically change based on the topic and based on the context of what the person's talking about, that might be a lot faster. What I mean by that is, chances are, if you're talking about your car, right, you're going to use words like engine, or like driver, or like mechanic, and stuff like that. So chances are that the word you're looking for is within that category. And I thought, if I can use context, I can exploit context, I will make these apps faster. So that's exactly what I did. So to do that, what I did is, in natural language processing and in any information retrieval subject, what you have to do is you have to get a wide corpus and to analyse and to perform techniques on. So I thought, what's the widest available corpus that we have is Wikipedia. Because Wikipedia contains every possible topic that you can think of so there's no limit to the actual conversation that the user could have. So I started off and I said, okay, I'll download Wikipedia. And I actually did, I downloaded Wikipedia. Yes, I did. It's, out of curiosity, it's only 9 gig, because it's all text. You know, they take out text and stuff. But then I thought, about 25% of the way, I thought, no, that's massive. My PC was getting slowed up. I even made a multi-core version of that, but it was taking 10 hours or something. So I thought, no. So what I thought, I said, I need to be smart about this. And I started using a naive-based classifier. And what a naive-based classifier is, it's a fancy word of saying you teach the computer to understand what the document is talking about. Okay. So I trained my PC to recognise when the documents were about these 4 topics. I decided on these 4 topics because when I was interviewing the speech therapist, she was so kind as to give me one of these communication books, right? She gave me one of these. I looked at the back of this and I thought, right, what are the topics? And there was loads, but I thought I'll start off with these 4 and see where that takes me. So I started off with food and drink, music, sports and transport, and I trained my PC to recognise when the documents were talking about these things, and then basically have about 70 documents for each class, for each topic. Then, what do I mean by NLP techniques? That's natural language processing. So, what you have to do in any information retrieval stuff is to actually parse documents, stem them, lowercase them, you know, the standard things that you have to do when analysing documents. And then all of these techniques are based on word co-occurrence, right? So to find related words, I used a technique called point-wise mutual information. Now, point-wise mutual information is a probabilistic technique that, based on frequency of words, is able to give you a value for how much the words are related to each other. So I was able to rank words based on their relatedness using point-wise mutual information, and I generated a lookup file that is the actual file that's going to be used by the application to look for related words. So the file looks like this. Say we have a word, right? And so you have a word and you have a wee arrow there, and it tells you all of the related words ranked based on that value given out by point-wise mutual information. Okay, so the more related the word is, the earlier it's in the array, basically in the queue. Okay, so how does the app work? I made a small prototype just to see how it would play out and if I was going the right way. So it's very limited at the moment, and it doesn't look like, it looks horrible, you can say that. Yeah, yeah, so as with any ASE, it starts off with the categories that you want. It's got a wee edit text at the top, and it's got a button to speak, so it speaks out. Yeah, and I mentioned before, because I know you're going to catch me at that. I mentioned before that the majority of apps are in the iOS, so I made my own in Android. So you know, yeah. So I knew that somebody was going to say it at the end, so I just I'll say it myself. Okay. So let's say we were using this, and we decide to talk about transport. Okay. So we're going to talk about F1 race. Okay, so we've selected the category transport, and here we have words based, they're ranked actually on their frequency within text. So the more a word is frequent, the earlier it would appear in this list. So, as you can see, we've got Air, Apollo. The reason why we have Apollo and Crew and stuff like that is because, obviously, my classifier selected documents about space missions and things like that, because that is a form of transport. Not very accessible, but it is a form of transport. Yeah, yeah. Well, you might never know. But anyway, since we're talking about F1, we'll select the word car. And that's where the lookup file comes into play. So, as I said before, chances are we're going to have a race, an engine, a series, a Ford, stuff like that. So, the reason you see a bit of weird words in there is because I've still to actually select my documents better. This was just a field test to see where the techniques that I used would take me. So it gives me the sense that I'm going in the right direction, but it needs refining. But okay, so it's a car race, and we select race, and then you have words about racing, who's winning the championship, Ferrari and stuff like that. And of course, because I'm Italian, the race was won by Ferrari. It's completely unbiased line. So that's how the user would use this thing. You would just be taking by a route based on relatedness, and I feel that would speed up the process of entering text in these apps, rather than the user having to select between massive amounts of words just placed in random order. So what did I do to develop this thing? So the process is actually comprised of two applications. The first application was a PC-based one, and it's the one that actually does all the processing in Wikipedia files. So we have the Wikipedia downloader, the parser that does all the pre-processing and stuff, and then we calculate all the relatedness, the word terms, everything that you need, the vocabulary for each category, all the files that are needed for the application. Because obviously what we don't want is for our AAC application to be doing any kind of processing, because we don't want to slow down the process. So it's all done beforehand, and all the application has to do is to read these files and look for the appropriate information. So, as I said, I'm testing this prototype, and shortly when it doesn't look that hideous, I'll go back to the NHS speech therapist and give her a feel, and hopefully you can give me ideas as well after, with questions and stuff. But what are the next steps? Well, as you saw, at the moment it's very limited, and as you might have noticed, we've only got lems in there. We've only got the actual, with no verbs, no verb teams, no plurals and stuff like that. So what will have to be included is a way of adding suffixes to words in a simple way that doesn't slow down the process. And also, to perform processing, I have to take out stop words, but obviously these will have to be included again, because you can't have sentences with no stop words. You sound like Tarzan. Yeah. So and also my hope is to actually broaden this by using a process called compansion. Now, the way compansion works is that you give your system only the main words of your sentence. So, say we use that sentence that I used as an example before, car race win Ferrari. The compansion process is able to give me all the actual alternatives for that sentence. So, the car race was won by Ferrari. Is the car race going to be won by Ferrari, and so on. So, the idea is to optimize the process as much as possible. So basically, the next steps are going to be about this, just reducing. In any HCI project, you want to reduce the amount of tasks for the user. You don't want to, and that's precisely the problem with the present legacy applications is that they have to do too much. They have to do too much, and that's the goal. So I'm going to finish out maybe a wee bit earlier, so there's more time for feedback and questions, because it's very important at this stage, because it's a very early on. I want to get as much feedback as possible. So thank you.
Thank you. Any questions?
When you do your file processing, so you've gone through and you've got all of your words, do you then hold those files locally, or does that still need to be connected?
No. They're held in device SD card or wherever. Yeah, they're not very big.
Okay, there was a question at the back somewhere. Yeah, Jack, you said, can it learn from the user? Can it then use what the user's doing, and then think, well, these are more familiar for this person?
Well, it doesn't at the moment, but it is an idea, because I don't know if you have a tablet or if you use it. So the tablet actually learns what you type, and it gives you the most. So I'm going to use that library within the tablet and put it inside the application. So it will learn the most common sentences that you type. So it is an idea. It is a next step.
Can it link to photographs or
Yes.
pictures, or can the word be linked?
That's part of the when I will have added all the functionality that I want, I'm going to turn the actual words into pictures, pictures and words, as with standard ASC.
Debbie,
is there a predictable function to it? So, if someone had an idea where they might want to start typing, say, a car.
Yes.
Will that be in it?
Yes. You can also use keyboard, and as soon as you press a key, it will start looking for that word and complete it for you. So it's just like a standard. It's got all the standard functionality that you would find in a normal typing application, plus the looking for the related stuff. Yeah.
Abby,
I was interested that you're, I suppose, like you said, you were just testing out the ideas at the moment. At the moment, your corpus comes from Wikipedia.
Yeah.
So it would generate very good, good descriptions of factual things, and the text is very based on kind of descriptions of events and kind of dictionaries and things. There's a corpora of, and that's different to spoken language in a lot of ways, isn't it?
It is, yes.
So I don't know if you've come across this, a corpora of